Okay, ladies and gentlemen, let's talk about congruence. Now, the idea of congruence, what does congruence mean? Now, if I want something that is congruent, that's going to be something that for now we're going to work with the definition of same shape and size. Now, this becomes important because we've just been discussing this idea right here, size. If I have A and B, and I have a line between A and B, and for now, let's call this 3 inches. Now, if I have another line over here that is C to D, and I measure it, and it also turns out to be 3 inches, that means the AB and CD are congruent. Now, are congruent. Now, that's fine if I write it verbally, but I probably ought to have some sort of symbol to do it. Now, you'd think that, well, we could put that guy right there, but the problem is that guy means equal. And that's not what we want, because these two are not equal. They are not indeed the same line. AB is over here, CD is over here. They are not the same thing. They happen to be the same length. They have the same size. And so we're going to need something similar to equal, but not quite. Now, some of you have seen this symbol. What does that symbol mean? It means approximately. Approximately. Well, these are not approximately the same length. They are the same length. So what we're going to kind of do is we're going to take these two, are going to get equal, and approximately like chicka-wah-wah, and put them together and come up with this symbol that has the equal sign, but then it has the squiggle on top of it, and it means congruent. So in this case, those two are indeed congruent. Now, congruence means, again, same size, same shape. We don't have to worry too much about shape yet because we're only dealing with lines. But if I have something over here, we're going to call it EF. And I have something over here. We're going to call it GH. These would be additionally congruent because I made sure that they were exactly the same length. So I would say EF, and don't forget your segment mark above it, is congruent to GH. Don't forget your segment mark. But I could do better than just congruent. If I have EF as a segment, I could also name it FE because it is the same length regardless of which end I start from. And so in this case, EF and FE, you could argue are congruent because they are the same length. But in fact, you can do one better than that. You can actually say those are indeed equal because they are exactly the same set of points, the subset of points such that the points, all points between E and F or F and E, it doesn't matter. It's the same exact points that you're talking about. So this is the only time you're able to use equal in terms of two geometric shapes. Otherwise, we tend to use congruent. Now, by the way, I said this is 2 inches. Is that correct? Well, EF is equal to 2 inches, but it's not EF the segment. That's a measurement. So we're going to put little m out front. The measurement of EF is 2 inches. Although some books are simply lazy and they say EF is 2 inches. And when you see it without the bar on top, it does indeed mean the measurement of EF. The only other thing that we need to take a look at when we're talking about measurements is that just because something looks like it should be congruent does not make it congruent. In fact, if I were to take and draw a picture of a stick figure and call this guy 6 feet tall, is this fella here also 6 feet tall? what is this dimension right here? You'd say, well, that can't possibly be 6 feet. This is 6 feet. That can't be 6 feet because I know that's smaller. Unless, of course, ladies and gentlemen, you're doing a perspective drawing. And this person simply happens to be farther back. If this is near and this is far, this could also be 6 feet. It's just he's farther away in drawing in perspective. So you need to be careful about assuming relative size. Something might be bigger or smaller based on its relative position. Okay? It's the same thing as when you try to squish someone's head by looking at the camera. Okay? Look, I can squish my entire head, even though if I just move it here, it's not even close to the same size. So how big is the marker? That entirely depends on how far it is from the camera. So 6 feet, 6 feet. In practice, this could be the same length, 6 feet, 6 feet, 6 feet, and 6 feet. It all depends on how it's labeled. If I label them all as 6 feet, then they are all indeed 6 feet. So that's something to think about when we're talking about congruence.